Good evening, ladies and gentlemen. Good afternoon. So, in our previous advanced calculus class, I gave my students these questions as an activity, and this is one of my students. Unfortunately, he answered most of the questions, but he had challenges with question number 3, so he has to do questions for question 3 too, and precisely question number 4. All right, so in this lesson, I'm just going to guide my students on how to answer question number 4. So we were asked to use the first principle to find these derivatives. So now, as we can see for question number 4, f of x, which is just y, so y, which is equals to f of x, is a constant. It is equal to 4. All right. So for all constants, when you're dealing with constants, your f of x is that. So what will your f of x plus h equal to? So you have nowhere to replace your x plus h, so it will just be 4. Okay. In other words, f of x is equal to 4x to the power 0. Okay, any number to the power 0 except for 0 is 1. And if we say f of x plus h, this will be equal to 4. Then inside x, we replace x plus h. Then everything raised to the power 0, and anything to the power 0 will still be 1. So this is just times 1, which is just 4. So we see that for any constant, f of x is that, and f of x plus h is that. So now if we are trying to find dy dx, or f prime of x, this is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h, of which no, okay, I don't have my second screen here to see. All right, so this becomes the limit as h approaches 0. What is our f of x plus h? That will be 4, since it's constant, minus f of x, that is also 4, divided by h. So we simplify before we apply the limit. So limit as h approaches 0, 4 minus 4, this becomes 0 over h. Okay, then which will be equal to the limit as h approaches 0 of h into 0, that will be 0. Okay, it will be difficult for us if we had a number over 0. This would be difficult because this is undefined. Okay, so from here, what we'll do is we are going to say f prime of x, which is just dy dx, is equal to the limit as h approaches 0 of 0. Now, the limit of a constant is that constant. Okay, so the answer is 0. Okay, so for instance, if you are taking the limit as x approaches 100 of 4, the answer will be this constant, which is just 4. It's a constant limit, so this is an example of a constant limit. Another example, maybe you are taking the limit as x approaches 3 million, okay, of 2. The answer will be 2. It's a constant limit. So the answer is 0 for this one. So yeah, so that is what you're supposed to do for this question. It's quite a very simple question, as you can see. So we see that y equals to 4. Then for dy dx, this is just equal to 0. So this is what you're supposed to do. Right. See you in today's lesson. Have a good evening.